Okay, so the last bit of probability, we've already talked about addition, multiplication, and what it means to have conditional probability. The last thing we need to talk about are... Alright, so we've talked about probability, addition rules, the multiplication rules, conditional probability. And now we're going to talk about how we can use two-way frequency tables. And it kind of sounds more complicated than it really is. We use them to help us determine the probability of an event occurring. So we're given a lot of information, and these tables, or two-way tables, help us to categorize and make sense of the data. So in this first example, we have utility patents that have been granted. Now, whether you know what a utility patent is, that's like the gears and how things are made for different gadgets and things like that. So in this year, there were 70,894 patents granted to corporations in the United States. So we're going to start filling in some of this information we have. So that's that 70,894. There were 921 patents granted to the United States government and 6,129 different patents granted to individuals in the United States. Notice how all of those line up with the United States row, and then they're separated into different columns. Then the next bit of information was 63,182 patents from foreign corporations. So 63,182. 104 were to foreign governments, and 6,267 to foreign individuals. 6,267. And notice these all line up in the foreign row. And then the last thing that we need to do is just add these up, and we're going to get the total. So we add up all the rows and all the columns. And there's not a particular order you have to go in. I'm going to add up my rows first. So all the U.S. patents, so that's 70,894 plus that 921 plus 6,129 is going to give me 77,944. I'm going to do the same thing with the next row. 63,182 plus 104 plus 6,267 is going to give me 69,553. Then the last thing I'm going to do is I'm going to add all the rows down. So all the corporation patents I'm going to add together, and I get 134,076. Then I'm going to add up all the government patents together. That gives me 1,025. Going to add up all the individual patents. That's 12,396. And then what happens right here gives me the total of the total. So the total patents all together. And this won't matter if I add the row or if I add the column. Either way, I'm going to get 147,497. So this is the total of the total number of patents. That's all the U.S. patents plus all the foreign patents in every category you can think of. That's the total. So now we're going to use this information in our table to help us solve some of these problems. So we have A, and A says, what is the probability that a randomly selected patent is a foreign patent given that it was issued to a corporation? Sounds more complicated than it is, like I said. So first, let's break it down. Let's see, how many foreign patents do we have? We have 6,267 foreign patents. Given that it was issued to a corporation, well, how many corporation patents do we have? So the total corporation patents is the 134,76. This is the total corporation. Did you see that? So the foreign, given that it was a corporation. So the probability of that is going to be the number of foreign patents over the total corporation, which is 6,267 over 134.76. And you can approximate that in your calculator. I think it's about 0.47 or 47%. All right, let's try another one. B says, I'm going to my new screen. All the data has stayed the same. I'm just on a new screen. Says, what is the probability of getting a patent issued to a corporation or a patent from the United States? So now we're talking about the probability that it was a corporation, or, remember that keyword or means to add, a probability that it's from the U.S. So let's see. Corporation, that's these guys here, and the U.S., that's these guys here. And something funky happened. What happened here? Well, someone's getting counted twice. Remember when they overlap, like in the deck of cards? We have this overlap. There's this overlap here, so we have to subtract that away. So we're taking out the U.S. corporations. So let's set up our, with numbers now. So, how many corporations do we have? Well, we have 134,076 corporations, plus how many total U.S.? We have 77,944, minus we have to take away those part that is overlap, so that's at 70,894. And all of this is going to go over the complete total, that's all, everything all together, 147,497. And when we do that, work out all these big numbers in our handy dandy calculators, we get 141,126 over 147,497, and we're going to use our awesome calculators to give us 0.96, or that 96%. Okay, and then we have our final question about this particular set of data. The probability of getting a patent issued to a foreign government or an individual from the United States. So let's write this out. We have the probability of a foreign government. There's that keyword there, or, means to add. The probability of a U.S. individual. All right, well, let's see. How many foreign governments are there? So foreign governments, there's 104. So that's our foreign governments. Plus U.S. individuals. So we're looking specifically for U.S. individuals, 6,129. And all of this probability is out of the same total. Remember, there's our total of that 147,497 And again, we can use our handy-dandy calculators. 6233 over 147,497, which will lead us to approximately a very, very small percentage of about 0.04 or 4%. Alright, so this time we have a little bit more data going on, and we're in the situation here from the 2000 Summer Olympic Games, and we have it's broken down from the United States, Russia, China, Australia, and then everyone else included in the Olympics, and what each country got gold, silvers, and bronze. So all this information has already been given to us, and all that we need to fill in are the totals. So all we need to do is add up every row, add up every column, and get those totals. And so let's see. I'm just going to start and I'm going to do my rows. So all the US, so golds plus the silvers plus the bronze, they had 97 total. And I'm going to do the same for Russia. Russia's golds, their silvers, and their bronze added together, and they have 88. Then we have China. Add up China's golds, their silvers, their bronze, and we get 59. I'm going to go right across, same thing for Australia, 58. And then everyone else left over in the others category is 626. Then we can add up all our columns. So now we're going to add up all the golds. So all the golds, there were 301 golds, 299 silvers, and 328 bronze, for a grand total of 928. Remember, this is the total medals of all the countries. Total medals all together. Excuse me. Alright, so the very first thing we're asked is to find the probability that the winner won the gold medal given they're from the United States. So this whole idea of being given from whatever, it just tells us that we don't really need to find the probability of how many golds there were out of everybody, just how many golds were there out of the US. So we have the probability of the golds out of the US. Well, this should be pretty easy. Let's see. How many golds did we have? 39. Out of total number of US was 97. Because I don't care about how many golds there were out of everyone. I just care how many golds there were out of the US. So the percentage was 39 golds out of 97 US, which gives me about 0.40, which is 40%. Pretty easy, huh? The tables make it really nice when you're doing the given conditional probability. It makes it very, very easy. And again, my table just changed a little bit, but nothing else happened. All right, find the probability that the winner was from the United States, given that they won a gold medal. So now we're still talking about the gold from the U.S., but now we're given that it was a gold medal, so our total is changing. So given that they're from the U.S. and won a gold. So it's the U.S. golds over the total golds. So that's going to give me 39 over 301, which is about 0.13 or 13%. Over 301, which is about 0.13 or 13%. And the last one. So the Vents medal winner is from the United States and gold medal was won. Are they independent? So basically we need to check what's the probability that you win a gold given everybody. So we have 301 total golds out of the total complete number of all the medals. And we want to see, is that the same as if you're a medal winner from the United States? So this ends up being 0.32 or about 32%. Which if we compare that to the probability we found in part A, which was, I believe it was 40%, they're not really close. So I would say that this is a no. Alright, so we've made it to our last problem. We have this auto mall store, kind of like a CarMax maybe, and they have different types of SUVs cars on their lot. They have SUVs, compact cars, like small 4-doors, 2-door cars, mid-sized cars, like your sedans, like Camrys, Corollas maybe, and they're also been categorized as foreign or domestic. So foreign cars are more of your like higher end Mercedes, BMW, Volkswagens. Those are usually made by people overseas. And then you have your domestic cars, which are like Fords, Chevys, GMs. Those are like the domestic kind of cars that are traditionally made here in the United States. So we have our totals, and this one's an easy one to add up. So I'm going to add up all my rows and all my columns. And again, you can go in any order. So you can add up the columns first if you want. Then you can add up the rows. Doesn't matter. And then we get all our totals. So we have our total number of cars down here, 300. Don't forget that means the total. So let's look at the probability that a car is picked at random that it is a domestic car. So we're just looking for the total number of domestic cars they have on the lot out of the total number of cars altogether. So we have 210 domestics out of 300 total cars, and that simplifies to 7 over 10. And then you can find your decimal percentage if you like. That's fine. Alright, pretty easy peasy. Let's look at part B. We have the probability that we're going to pick a foreign car and mid-size. So let's see. We need the foreign. So we're looking for the foreign. How do you spell foreign? Foreign mid-size over the total number of cars. Well, let's see, how many foreign mid-size do we have on the lot? And according to our data, we have 20 out of 300 total cars, which is about 1 over 15. Okay, so far so good. Let's see, we're looking for the probability that we pick a domestic vehicle or an SUV. So this one's a little bit different. So we're looking for the probability of the domestic, or means to add the probability that we pick an SUV. Well, let's look. So SUVs, there's our SUVs, and our domestics. There they are. And what happens right here? They overlap. So we have to subtract that away to make sure keep everything even, that none of our cars are getting counted twice. So we have to subtract the domestic SUVs. So don't forget that part. So we have our total number of domestics plus the total number of SUVs minus those that are being counted twice, or 65 of them. And all of this is over our total of 300, which is going to give us 230 over 300. which will simplify to 23 over 30. And again, you can find the decimal for that as well. Remember that the probabilities could be written as fractions, they can be written as decimals, and they can also be written as percentages. So make sure you're aware of that and you can connect all three representations. And let's see our final one, D. The probability that it is a foreign car given that it was a compact. So we are looking for our foreign compacts, remember that's the and, they're both, over the total compacts. Remember this is the and one. So our foreign compacts, we have 50 of those, over our total number of compacts is 150, and we get a total of 1/3, which is about 0.33333 repeating, which is about 33.3%. So that is probability in a nutshell.